Hi, thank you everybody for showing up for this webinar. My name is Wissam Jallouli. I'm a specialist with Factory One, the first capability building center in the GCC, powered by QDB in collaboration with McKinsey & Company, where we train SMEs for better operational performance. For more information about our training and services, you can visit our website, www.factoryone.qa. So in today's webinar, we will be covering robotics in manufacturing and how it gives significant advantage for all SMEs. For that, we will start first by defining what's a robot. Then we will discuss a little bit the history of robots and the different types. And after that, we will explain the impact of robotics in manufacturing. And then we will illustrate the trend toward robotics. And finally, we'll give you some tips on how you can select the best robot for your application. So, what is a robot? Robot is defined as a programmable machine capable of carrying out a complex series of actions automatically. It can be controlled by an external control device, or the device or the control could be embedded within. Nowadays, the International Organization of Standardization, or shortly called the ISO, defines industrial robot as an automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes, which can be either fixed in a place or on a mobile platform for use in industrial automation application. In engineering, mechatronics is considered as a branch of technology that deals with the design, construction, operation, and application of robots. As you can see, we have the computer part or the IT parts in robotics. We have the electronics parts with the control and also with the mechanical system. So let's talk more about the history of robots. You will be very surprised by the early stage of robot inventions. In the beginning, before the use of the word or of what we know robot, in the ancient literature, people used to call automaton to define a relatively self-operating machine or control mechanism designed to automatically follow preparations or response to predetermined instruction. Some automata are designed to give an illusion to be casually observed for the casual observer that they are operating under their own power. As you can see here in the first photo on the left, this is Archytas dove. Archytas is said to have designed and built an air or steam-powered wooden dove that was capable of flapping on its own. This was 350 BC, where the air was released and it has a casual. It causes the bird to flap its wing and mimic the flying mechanism. The next example is from Susong. It's a 10-meter clock tower featured with the mechanical mankins that chime the hours and rings bells among other devices. And we go after that to very known scholars. I think everybody knows Abu al-Izz ibn Ismail ibn al-Razzaz al-Jazari. He invented many mechanical systems, and he's considered as the father of advanced mechanics, where he developed a lot of mechanism, and it's all captured in his world-known book and the knowledge of ingenious mechanical devices, or in Arabic, الجامع بين العلم والعمل النافع في صناعة الحيل. Moving to an advanced era, we have the Da Vinci Nights. It was done by Leonardo da Vinci, where he had various contributions in the field of automatons, and his personal notebooks are littered as with ideas of mechanical creation ranging from hydraulic water clock to robotics lines. The next one is the Silver Swan. The Silver Swan, and the good part of the Silver Swan, it's still functional. From the 18th century, it is avian automation originally constructed by the showman James Cox and watchmaker John Joseph Merlin in 1773. Same thing with the Silver Swan. It mimics the flying, and it can make sounds as a singing swan. Moving now to another example of robotics, which is the Jacques Droz 3 automatons. Where you can see from the right, there is a small doll that can write. The one on the left, the small boy, he can draw, and the one in the middle can play piano. This was done in the 18th century purely with hydraulic, meaning with air power and water power and a couple of gears. Jumping now to 1973, where KUKA Famous Robots was the first pioneer, where KUKA wrote history as a robotics pioneer with the world's first industrial robot with 6 electrical motor-driven axes. And in 1986, Puma have introduced the Unimate, the first digitally operated and programmable robot. It was invented by George DeWalt and represent the fundamentals, the foundation of the modern robotics industry. In 1989, Honda began its humanoid research and developed a program to create robots capable of interacting successfully with a human. Hexapod robot named Gengis was revealed by MIT in 1989. Gengis was famous for being made quickly and cheaply due to the construction method. Gengis used like 4 microprocessors and 22 sensors with 12 servo motors. Jumping now to 1969 with Honda. Again, Honda continue, as you can see, working on their experimental humanoid robots, where they have introduced the P2 series, which is standing for prototype model 2. This is why they called it P2. P2 was integrated part of Hyundai Humanoid Development Project. It was like 1.8 meter tall and was smaller than its predecessors. Moving now to 2001, where Canada was sent to outer space as the first manipulator and the first robot to go out of space. And in 2011, we have introduced Robonaut as the first astronaut helper, a humanoid astronaut helper. This was like brief introduction for the history of robots and how it got evolved in industry. And as you can see, we have a different field where we can see robots on Earth and even in space. Let's move now to the different types of robot. We can categorize robots in 3 main divisions: stationary robots, wheeled robots, and legged robots. And then out of these 3, we have what we call diversity robots, where we can find robots like swimming, flying, and multiple hybrid robots, snakes robots, and so on. For the stationary robot, we can find them the most in industry. These are the most adopted robots inside a manufacturing company or manufacturing field. Where we start defining the Cartesian robot, it's a 3-axis robot. This robot, we can find it a lot in CNC machine and 3D printing machine, where the displacement is based on X, Y, and Z axis. We have also the cylindrical robot. This is where the robot, it covers a cylindrical working environment or work space. And we have the spherical robot, where the robot can cover a spherical environment. The SCADA manipulator, this is basically used for most for pick and place activities. And we have articulated robots, meaning with 5 axes and with above 5 axes robot. This used for welding activity and especially in automation. Finally, we have the parallel robot, and this is basically a subdivision of a stationary robot, where even the control of this type of robot is very, very sophisticated, because it's based on a closed kinematics loop, where all the past robots that we have cited is an open kinematic loop. In the wheel robot, we have different types: omni wheel, 4 wheels, 3 wheels robots. These are service robots. And finally, we are dealing with the legged robots with 1 and 2 and even more legged robots. Going now to understand the impact of robotics in manufacturing. So basically, we have a variety of robots, a variety of utilization, a variety of application of robot, but one can ask, what's the impact of adopting robotics in our daily manufacturing life? Studies have revealed that investing in robots contribute 10% of growth in GDP per capita in OECD countries from 1993 till 2016. The OECD countries are basically Australia, Europe, and North America. So why this contribute in the GDP? Because robotics increase productivity and increase production. They are more accurate than human. They make fewer mistakes. They reduce wastages. They are more reliable than human. They can work 24/7, and they are very, very quick, which saves time. They don't complain or get tired, and especially they can do dangerous work in hazardous environment. McKinsey Global Institute predicts that up to half of total productivity growth needed to ensure a 2.8% growth in GDP over the next 50 years will be driven by automation. Now, if we increase the number of products, everybody will assume that we will lose a lot of jobs. In recent studies, we are no longer talking about losing job, but we are talking about reallocating job. Automation does not lead to a job substitution, but it leads to a job reallocation. Labor demand increases by 11.6 million jobs due to computerization between 1999 and 2010 in European Union. While technology has potentially contributed to the loss of over 800,000 lower skilled jobs, this loss in lower skilled job, it got transformed into 3.5 million new higher skilled jobs. So we are moving from a labor who only making pick and place, like a very low skill activity, this labor could be substituted by a robot, while we can train this labor for a higher and more Speaking now about the trend toward robotics. As you can see in the graph on the left, this is the operational stock of industrial robots worldwide. This is per 1,000 units. As you can see, in 2010, we have almost 1 million robots installed all over the world. However, this number got tripled to 3 million robots in 2020. And this is a huge step toward automation. The annual installation of industrial robots around the world, it went from 121,000 installed robots in 2010 into almost 400,000 robots in 2022. So this shows that the world is racing toward integrating more and more robots. In this graph, we see the annual installation of industrial robots by customer industry. So the one on the left, it shows you what are the industry who adopted the most robotics. We can distinguish three main industries that they are heavily automated, which are the electrical and electronics, the automotive, and metal and machinery. These are heavily automated. Now moving to the graph on the right, so among these industry, what are the application, the most common application that we use robot for? Basically, we use a lot of handling, a lot of welding, and a lot of assembling. Moving now to understand which countries are using robots or installing the robots the most. As you can see on the graph on the left, we can see United States, or both the Americas, the Southern and the Northern Americas, they comes third. Then we have Europe, then Asia and Australia are the most places that they use robotics in their industry. And in the graph on the right, you can easily see the top 5 companies, the top 5 countries: China, Japan, United States, Korea, and Germany as leading countries in robotics installation. Trying to understand now the robot density in manufacturing industry. This graph shows in 2022. This is the robot installation per 10,000 employees. We can see that Korea, Singapore, Japan, Germany, and Sweden are heavily relying on robotics. It's clearly showing that with the countries with a very cheap labor, they are adopting robotics. This rings a bell that robotics are coming in industry in everyday's activities. The graph on the right, it shows the trend or the projection for the robots installation. And we have an annual growth for robotics in post-pandemic, hopefully, if we can get it out as soon as possible. So basically, that's it for today. So I'll try to give you like small tips on how to select a robot and what are the common factors that you need to take into consideration for you when you are trying to choose robots for your industry. So first of all, when approaching an investment in robotics, we should consider all aspects of an applications prior to making a final selections. Hence are some of the more important factors to consider. First of all, we care about the application. So before choosing your robot, you will start questioning, what's my application? Is it welding activity? Is it pick and place applications? Is it transporting activities? This will define a family of robots where you can choose one family for your specific application. The second point is the workspace. So basically, it's how many cubic meter you are covering. You want this robot to cover. Is it 1 meter by 1 meter by 1 meter? So where you are going to put your robot and what's the reach of your robot. The third point is the payload. The payload is how many kg this robot will carry and will transport from point A to point B, or how many kg the end effector or the last point of the robot that execute the job will be waiting. Fourth point, which is how many degrees of freedom. So this is basically the flexibility of the robot. Do you have a straightforward application X, Y, and Z, or you need to access to a very narrow area and you need a very flexible robot with a high degree of freedom. Next, let's talk about environment. Are you putting your robot in, for example, in a painting shop, or you are putting your environment in hazard, or you are putting your robot in hazard environment where probably you have toxic gases, you have electricity, you have high working temperature that you want your robot to work within. So we need to take into consideration the environment that we are going to put our robot in. Next point, precision and accuracy. How precise and how accurate my robot is going to be. Do I have like a nano technologies, or I am using this robot with a wide range of accuracy? Let's define precision. Precision is how close measures values are to each others, while accuracy is how close a measured value is to the true value compared to the true value. This is some difference between precision and accuracy. And last, maintenance. We need to get a partner that can maintain our robot. We need to get qualify our people to maintain our robots, to program our robot. Do we have the right service provider to deal with? Because once you get a robot, you will get the service with it. So a lot of company like KUKA, like ABB, like Schneider, Universal Robots, you have a lot of brand, but which among these service providers or robot manufacturing, we have Fanuc as well, one of the leading, which one of these manufacturing will be the right partner? So thank you so much. Basically, this is it for today's session, and I will be more than glad to answer your question. Yes. Again, thank you so much, everybody, for showing up to this webinar. Please, if you want to know more about robotics and about lean manufacturing, please visit our website, factory1.qa. Thank you so much.
Thanks to you, Mr. Sam. So I didn't receive any questions, so I'll wrap this up. Dear audience, thank you so much for attending today's session. I hope you find it beneficial and fruitful. See you in our next workshops.